Okay,
This
perfect.
conference will now be recorded.
All right. Hello, everyone. We have given a few minutes for people to sign on, although I still am hearing some chimes, so we'll probably get some more. Thank you so much for joining this webinar today to dive into two soil moisture products as we look at these for the Midwest. And sorry, let me just make sure just a reminder that if you are not muted, to go ahead and mute yourself if you're not speaking. But thank you for joining today, and thank you especially to the developers of these two products for preparing the presentations and joining us to talk through the products and to answer questions and all of that. So before we get going, we do want to just do a quick round of introductions. So feel free to turn on your cameras if you would like as we do this. And I would like it to be fairly quick, just your name, your title, and who you're affiliated with. And I will call off, just kind of go down in order of who I see on GoToMeeting. So I will start. I think I know most of you on this call, but for those that I don't know, I'm Molly Wolozin. I am with NIDIS, the National Integrated Drought Information System, and I coordinate our Midwest Drought Early Warning System, or DEWS. So that region basically makes up 8 states within the Midwest, and I'm really happy to have all of you joining today. So next, Marina, do you want to go ahead and introduce yourself?
Yes, welcome everyone. My name is Marina Skumanich. I know many of you, but not all. I'm glad to meet you. I'm NIDIS staff support to the National Coordinated Soil Moisture Monitoring Effort, which is that national interagency effort to build soil moisture data sources and deliver data products. And I know many of you are involved with that, including the developers today. So thank you all.
Great. Aaron Wilson.
Hi, everybody. I'm Aaron Wilson. I'm with Ohio State University. I share a joint appointment between Bird Poll and Climate Research Center and OSU Extension, and work a lot with the State Climate Office. I think that's about it. Thanks.
All right. Chip Zimmer.
Hi, this is Chip Zimmer with the Kentucky Division of Water, and do the drought monitoring for the state.
All you. And I know I was messaging with you, Chip, today, but just thinking of all of you in Kentucky and hoping that you all are doing okay. Definitely have been on my mind quite a bit. Okay, next up, Christopher Hain. If you're speaking, Chris, we can't hear you. Okay, maybe if you just want to quickly introduce yourself in the chat box, and then maybe we can get audio later on. But Dennis.
Yeah, Dennis Toddy, Director of the USDA Midwest Climate Hub, recovering state climatologist, and help out with some of the drought monitoring around the region.
Great. And I'm sorry if I pronounced this wrong, but Ileana, sorry if I didn't get that right.
Yes, thank you. My name is Ileana, and I'm at the Ohio State University, and I'm with nationalsoilmoisture.com.
Wonderful. John Case.
Hi, good morning, everyone. I'm with the NASA Short-Term Prediction Research and Transition Center, that's SPoRT, out of Huntsville, Alabama, and I'll be presenting on the sports version of the land information system today.
Thank you. Justin Fisher.
Hi, I'm Justin Fisher. I'm with the North Central River Forecast Center in Chanhassen, Minnesota.
Great. The other Justin.
Good morning, everybody. Justin Glisson, State Climatologist of Iowa with the Iowa Department of Agriculture. Coordinate the drought monitor effort here in the state and use the SPoRT products almost on a daily basis.
Wonderful. Kevin?
Hi, I'm Kevin Fuel. I'm at the University of Alabama, Huntsville, and I work with John Case and Chris Hain, as well as Chris White. supporting the NASA SPoRT program, and I work mostly in the transition area to do user engagement, training development, and assessment of products, and have helped John and Chris develop various training and do transition of SPoRT list type products and fields.
Great, glad you could join us today. Christopher White.
Hey, good morning. So yeah, I'm Chris White. I recognize a lot of names here, by the way. Some of you may recognize my name, at least through emails. Anyway, so I'm the applications integration meteorologist, and with that, I am actually a National Weather Service employee who is, I'm a senior forecaster at my office in Huntsville, Alabama, but I spend half my time with the NASA SPoRT program as well, helping to transition and acting as sort of a consultant, an operational meteorologist consultant for products, and helping to transition those and evaluate those as well, including the SPoRT list, which we're about to present on here. So that's all for me.
Great. Zach.
Hi, good morning, everybody. My name is Zach Leeser. I'm a postdoc at Ohio State University, and I help to work on the National Soil Moisture Network.
Masha Hoy.
Hi, sorry I can't get video on, but I'm a river forecaster at the North Central River Forecasting Center.
Great, thank you. Melissa.
Hi, everyone. I'm Melissa Widhelm, Associate Director and Regional Climatologist with the Midwestern Regional Climate Center located at Purdue University in Indiana.
And Rajat.
Hi, I'm Rajat Binlish. I'm at Goddard Space Flight Center. I'm involved with the soil moisture missions, SMAP, as well as NISR, and I will be presenting the crop CASMA along with Zhengwei.
Great, thanks. And I see two Rays, but I know Ray Wolf is on the phone. So let's start with you, Ray Wolf, and then we'll see if there's another Ray.
I'm the Science and Operations Officer for the National Weather Service in Davenport, Iowa. And among other job tasks, I support the regional and national climate programs.
Thanks. And the other Ray without a last name.
Ray Davis with the Ohio River Forecast Center. I'm a river forecaster.
Great, thanks. Scott.
Hello all, I'm a hydrologist and river forecaster at the National Weather Service North Central River Forecast Center.
And Steve Buin.
Yeah, good morning. I'm Steve Buin, the hydrologist in charge at the North Central River Forecast Center, and we're interested in these products, and that we've been striving for decades to use soil moisture observations or depictions of it to help in our hydrologic outlook process, our seasonal outlooks.
Great, glad you could join, and so many of your staff. Stephen Quiring.
Good morning, Stephen Quiring. I'm a professor at Ohio State University and a climatologist focused on soil moisture and land atmosphere interactions.
Great, Trent.
Yeah, hi, I'm Trent Ford, the Illinois State Water Survey, and I'm help with the regular drought monitoring here in Illinois, and I also do quite a bit of soil moisture research, both with observations and models.
And last but not least, Zhengwei.
Hi, this is Zhengwei from USDA NIDIS. Yeah, I'm a remote sensing application research scientist, and we are using that soil moisture, remote sensing soil moisture data product for agriculture land soil moisture condition assessment. Yeah, Raja and I will present the crop CASMA.
Great, thank you. Did I miss anyone that's on the call? All right, thank you so much. I will go ahead and hand it over to Marina to kind of give us a quick overview of the webinar, and then we'll jump into the first presentation. So Marina, and feel free to turn off your camera. Actually, that might be preferred just for bandwidth. And then we can always turn it back on during discussion. So thank you. Go ahead, Marina.
Right. Well, again, welcome everyone. Really excited to have this opportunity to be with you today. And we're gonna look under the hood and kick the tires of a couple tools. So we know there have been a number of presentations on these tools, and many of you may have been a part of them. But often it seems like we just don't quite have enough time to really ask some of the questions we have, or if we've used the tool a little bit, it sounds like some of you have on these tools, and maybe you want to follow up on something with some experience you've had. And so this is our opportunity to do that. We purposely chose not to have a webinar, but instead have this meeting format so that we are all really sitting around a table right now, and we're going to be having a presentation first on each of the tools and then opening it up for back and forth discussion. We're sort of planning that this process should probably be like about a half an hour per tool, 10 or so minutes to present, and then 10-15 minutes to talk about it. But we did schedule for an hour and a half, again, specifically to allow for robust back and forth. So so often we get cut off on these things. We were ready to ask a question, but we run out of time. So, but we'll see. This is our first one of a series. Now we're going to do 5 of these, or 6 maybe. Again, every time 1 or 2 or 3 perhaps tools that we'll review in this format. So as our first one, this is a little bit of an experiment, and we'll see if an hour and a half is what we need. But thank you all for making the time to come here today, and again, thanks to the developers for being willing to come here and run the gauntlet a little bit. We're hoping in the spirit that it always helps to get good questions. It always helps to sort of acknowledge the places where your tools work best and where they don't work, and then together we can make these tools better. Because again, from this National Coordinated Soil Moisture Monitoring Network perspective, we all know, as one of you mentioned, that it's been years people have been saying we need better soil moisture information feeding into our decision making. So this is one step in that process. It's a good back and forth, we're hoping, between those of you developing tools and those of you using them. So you've got the agenda before you, and so we'll be going to be starting out just for no reason, but because we contacted them first, SPoRT LIS. So Jonathan Case will be presenting with Chris White providing a little bit of commentary on the way. So again, starting, well, we're just even still on time. So starting just in a moment, and then again after that we'll have after the presentation we'll have the question and answer on that tool, and then turn to crop CASMA. And so we've got the agenda here, and again, as an experiment, we'll see if we stick to it, but we do have that whole hour and a half if we need it. So Jonathan, I'm gonna, Molly, anything else I should add now before we start?
Nope, I think we're good to go.
Okay, so Jonathan, I'm gonna go ahead and change presenter to you.
Thank you, Marina. And I realized I did not give any background about my area of experience, but at SPoRT, I run land surface models and NWP models and do verification, and I'm the manager of the real-time SPoRT LIS for a number of years now. And so I'll give you some brief background on that. I won't belabor any individual slides here. Let me go ahead and presentation mode. So are we sharing successfully here?
We are.
Excellent. So the NASA Land Information System is, we've been running this for several years now. And let me first start off, spend about a half a minute on what SPoRT is, in case those may not be familiar with that. So we've been around for about 20 years now. We're predominantly NASA and partially NOAA, and funded by some other external and soft money projects. But we specialize in R2O and O2R. And really one of the keys to our success is to continually engage with the end user and the stakeholder in the process of developing, evaluating, and assessing products. And so we don't just write a paper and throw it over the fence. We really try to match a specific research product and develop a prototype solution that fits the end users need for operations. And we work closely with them in that potentially iterative process. And then if it's deemed fully transitionable, then we hand it off, or we stand down if it becomes a fully operational product. And so today I'm going to be describing our version of the land information system that we're running over CONUS. And this is just a diagram of how the land information system framework operates. There's a series of land surface models at its core. And really, this is a high performance optimization of a software framework for doing parallel computing and diagnostics. And the LIS takes in a variety of input fields. You force a land surface model with the atmospheric and static and time varying inputs. And you output information about soil, water, and energy information. And then there's an optional layer for data assimilation, and then also an optimization and uncertainty analysis for optimizing parameters. And so in our instance, we're really running the most simple form of LIS for the real-time SPoRT LIS, and that's just taking in the input fields, the atmospheric forcing, and running it through the NOAA land surface model. We do have a parallel version of SPoRT LIS running in which we assimilate SMAP retrievals level 2 information on a regular basis. And there's a slide on that as well. So a little bit about the SPoRT LIS configuration. We have a full CONUS domain at approximately 3-kilometer grid spacing. It's fundamentally based on the NL-2 analyses and forcing from 1981 to present. But the NL-2 has this problem with 4 days latency. So we bridge the gap for that latency to produce near real-time output by switching over to GDAS and MRMS hourly precip to bring us up to just about real time. And then we also have a forecast component currently with the GFS forecast model, but we're exploring the ideas of producing perhaps ensemble output of SPoRT LIS with GEFS as a possible example. We have a climatology that spans 33 years, and we generate percentiles off that climatology. One thing that's unique about the SPoRT LIS compared to other LDASs is that we incorporate real-time satellite vegetation fraction products. And in this instance, we've been incorporating the VIIRS GVF since about 2013 of our LIS run. So therefore, if you have anomalous vegetation response to either drought or a pluvial scenario, the vegetation will adjust compared to just throwing in a climatology into your land surface model. And we transition all these products, or select number of products, into AWIPS-2 for a variety of National Weather Service and RFC partners. And we've even used these for local NWP initializations, providing that to the National Weather Service version of the WARF model. So I'm going to step through these really quickly because these are just examples of the variables as displayed in the NWS AWIPS-2. And so this is the selection of the types of variables. We have shallow and deep soil moisture. RSM is relative soil moisture or available water. And since AWIPS has a pretty rapid purge cycle, we generate change fields that we include in the AWIPS stream. And I don't know if Chris White, did you want to chime in at this point to describe some of these and how your experience has been in using these within AWIPS-2?
Yeah, I could just mention that the data in AWIPS-2 may not necessarily mean a lot to many of you. This is primarily for National Weather Service system and functions and applications of the data there. But yeah, so I began using the SPoRT LIS and feedback through the state climatologist for the drought monitor about a decade or more ago. And then when I found out about the relatively high resolution and low latency aspect of this data set, and of course, while I was working or began to work with NASA SPoRT a little bit after that, then it was very advantageous, those two aspects of the data. So one of the other things that I ended up requesting is for them to be a little bit more pertinent for feedback to the drought monitor, were these changes on timescales initially of a week, because feedback to the drought monitor takes place on a weekly basis. And so I said, rather than having to kind of flip back and forth online between images or looking at and comparing images kind of in my head as best as I could, changes in deep layer or root zone soil moisture over a period of a week, it would be nice if you could generate just changes in those soil moisture variables. And so the team did that. And also ultimately it is important for drought analysis to have some sort of a, what do the data mean in the context of a climatology? And so then the SPoRT group did that. And I think that's maybe the next, if you hit next, John, there's just an example of the data. That's actually a year change. So yeah, you'll notice that in addition to weekly changes, there's 2 week, 1 month, a season, half a year, and then year. So sometimes it's interesting to look and see like, well, what did we have this time last year for the drought monitor, and how do we compare? Not that it's just soil moisture, but sometimes it's interesting to look at that and see how your soil moisture may compare with where your drought, what category you were in the previous year. And maybe largely just for weather service purposes, there's soil temperature data too, and then GVF. Go ahead, John.
Yep. So the real-time vegetation we also provide in that stream, since it might be interesting to take a look at some of the vegetation. And on our webpage, we do changes in the vegetation on similar timescales as the soil moisture. So let's dive briefly into this soil moisture climatology and how we construct it. So this is really a lot about the model configuration, but what we're most interested in is that we did a 30-year spin up, then we went back and restarted toward the beginning of the climatology and then ran through the atmospheric forcing again to come up with this 33-year input. We actually restarted back to 1979, so that way we had 2 additional years of restart spin up before coming up with the climatology in an equilibrium state. And so what we did initially was somewhat unique, is that we grouped all of the grid points into a county by county basis. So every county across CONUS had its own 33-year soil moisture climatology. And then you could look at histograms of the distribution of soil moisture across any given county. And then you could rank how the mean value in your county compares to this histogram. More recently, we've done more of the classical grid point by grid point soil moisture climatologies, where we have a 7-day moving window centered on the current day, and we do cumulative layer climatologies for 0 to 10 up through 0 to 200 centimeter depth. And then we compute the percentiles based on those cumulative layer climatologies. And we followed, the proxy drought index convention that Yulong Chia published back in 2014 to come up with, the proxy percentiles that are colorized the same as the drought index. And then on the moist side, you have, light green to blue for the moist anomalies. And so just some validation that we did several years ago, we looked at a little over a decade of our proxy soil moisture percentiles coming out of the full column relative soil moisture percentiles, and we evaluated them over these 3 different subregions. And first, pictorially, it looked reasonable, compared to the drought monitor, particularly over the eastern US. Over the western US, you have a lot more noisiness, changes, variability in land use and elevation, and also a lot more factors go into the drought monitor beside just soil moisture in the western US. But we looked at time series of the proxy LIS drought categories and compared them to time series of the actual US drought monitor product for these 3 different subregions. And we found that the time series matched visually the best over the southeast US, where you have frequent rain and alternating rain and dry episodes. And it's more well behaved in the eastern and southeastern US. The Great Plains was pretty well captured as well. And then you can see in the northwest US, we tend to underestimate the lower category of droughts, but then overestimate some of the extreme values of drought, at least from this 2006 to 2015 period we evaluated. And some of the statistics that came out of this validation, we looked at the bias in the aerial coverage of our SPoRT list proxy drought categories compared to US Drought Monitor, and similarly the correlation statistics. And you can see how well almost all the drought categories correlated to just using the simple soil moisture percentile proxy out of the LIS. And even over the Great Plains, the correlations were quite good. And then it broke down, as you can see, particularly for the higher drought categories in the Northwest US. We've had a variety of evaluations and applications that we've used the SPoRT list in over the years. We started off with some partnerships with National Weather Service end users, and they looked at evaluations and assessments. And Chris alluded to some of the feedback that we would take in from the NWS offices in terms of what did they need in their decision support systems that would help improve their evaluation and use of the product. Forecasters would complete surveys and blog posts in order to highlight the utility. And then since those evaluations with the NWS offices, we've seen a variety of our partners have contributed to drought assessments and US Drought Monitor adjustments in their local regions, areas of responsibility. We've worked up some examples and case studies on soil moisture evolution associated with flooding issues and leading up to wildfires. One of our partners looked at using SPoRT lists as a situational awareness tool to assess blowing dust risk associated with southwest monsoon convection. And more recently, we've been exploring machine learning and AI applications where SPoRT lists inputs go into a machine learning algorithm. One example is looking at tree fall associated with landfalling hurricanes, and then also a deep learning model to predict the stream flow and height associated with a basin. And one of the deep learning model is applied uniquely to each individual basin. That's an exciting area that we've been seeing some good results out of. And let's step through pretty quickly. I won't belabor these, but we had a assessment of the soil moisture product leading up to the Gatlinburg, Tennessee wildfire event in 2016, where the fall of 2016, we had exceptionally warmer than normal and very dry conditions throughout the Southeast. And you can see the tremendous expansion of the drought monitor categories, and the list really behaved similarly to that. And we looked at these county climatology histograms, and this is what it looked like the day before the wildfire event in Gatlinburg County. And this dashed line represents the mean soil moisture in the county relative compared to the histogram, and it's essentially proxy between the D3 and D4 event. And here's a time series analysis from during the year of 2016 leading up to the wildfire, where we had extremely low percentiles prior to that event. And then you can see a big jump because we had like 3 to 5 inches of rainfall following that episode. And then on the opposite side of the spectrum, we looked at the behavior of SPoRT lists associated with exceptional rainfall events with landfalling tropical cyclones. And we looked at some of the classic events that we've had recently. The Joaquin event, where it stayed offshore but interacted with a trough, and South Carolina had up to 30 inches of rain. And of course, Hurricane Harvey, and then Hurricane Florence again in the Carolinas, and then again over Southeast Texas, Tropical Storm Imelda. And the post storm soil moisture percentiles showed this exceptional area of greater than 98 percentile soil moisture across the regions. I mean, Hurricane Harvey was just off the charts, you know, huge coverage, and soil moisture is off the tail of the climatology. And then a quick animation of how the soil moisture evolved with Hurricane Harvey's landfall, and you can see the MRMS contours. They're not labeled, but you can see it just raining and raining, and the soil moisture becoming saturated in the top 1 meter associated with that event. And day by day, the mean across the Jefferson County, which is Beaumont, Port Arthur, Texas, the values were fairly close to the median of the distribution, but then in one day it went up between 95th and 98th percentile, and then the mean across the county was completely off the tail of the 33-year climatology distribution. And I alluded to the parallel run of SPoRT LIS that we have going with SMAP data assimilation, and we've been assimilating the SMAP data regularly since April 2015. And we also have OCONUS applications, different configurations of LIS. We have a 1 kilometer version running over the entire Caribbean, and predominantly to help out our partners in San Juan, Puerto Rico office. But we do have, we generate geotiffs. This is an example of what the domain is, and we provide geotiff output for some of our end users that use GIS applications. And then we had some international collaborations with the Kenya Meteorological Department, and we provided the LIS run for their soil moisture assessments over Eastern Africa. And finally, Dr. Clay Blankenship, another SPoRT personnel, he's been developing an Alaska LIS run to look at hydrology applications during the snowmelt season, and then also soil moisture situational awareness for the wildfire season in the summertime. And we also ingest the real-time VIIRS vegetation into that configuration as well. And here's a list of some of the peer-reviewed articles. And with that, hopefully I didn't go over too much. And that is our background on SPoRT LIS. So thanks everyone for their attention.
Yes, thanks very much, John. No, you didn't go over too much. And in any case, it's important. So let's see, we can stop. Having a little trouble. I can share with myself, but I don't know how otherwise to. Okay, so I'm going to share and then I'm going to stop sharing. Sorry, everybody. Although having done that, people may have some questions about your slides, John.
Yeah, do we want to take any questions now, or do we want to just go through both presentations and field questions at the end?
Now. Yeah, we want to take questions on yours.
Either way.
Yeah, we'll start with yours right now, and then we may circle back afterwards if there are some other ones. But so let me again invite people either in the chat box or turn on your camera, or I don't think we have a raise hand on this
I see a question about frozen soils that showed up. I missed who asked that question, but
Dennis Toddy, go ahead.
Okay, so in terms of frozen soils, and I heard this on the Southwest NIDIS call just yesterday, but the land service model within LIS is going to handle it similarly, in that as soon as the soils freeze, whatever the state of moisture is in that soil is going to essentially remain unchanged until the soil thaws out, either if it takes it the whole season, the winter season. And I've seen that behavior over the northern plains, where a lot of times when you have a very dry soil state and then it flash freezes and there's no ability to infiltrate into the soils again until they thaw out. So if it's a dry soil state, and you have a good snowy winter, you're gonna have to wait for that soil to thaw and the snow melt to infiltrate to recharge the soils. think Marina's
Hey, Jonathan.
unmuted.
Did you have a
Yes.
question? Go ahead. Sorry.
Hey, Jonathan, this is Chip at Kentucky Division of Water.
Hi,
Has
Chip.
there been some type of change to the model recently? Because I know in the past it's worked great, and this fall we've had a lot of problems in Western Kentucky where all our mesonet stations say soil moisture is good, and SPoRT has just been continuously showing dry, D1, D2 caliber dryness in the soils, and it's been kind of an issue with drought monitoring because some people are wanting to put it in D0, and we're like, no, soil moisture is great out there. So there's some type of disconnect going on out there right now, and I didn't know if something changed or.
Have you noticed that it tends to be like a bullseye shape in the dry areas in places?
No, it's spread across the whole. It's been spread across, extending from Tennessee and Missouri and Illinois. It's just been the whole area.
Okay, yeah, that we may need to explore that a little more closely because we have seen issues with the NL-2 inputs recently in the last year or two where we're seeing some degradations in that input precipitation coming from NL-2, and it's resulting in small circular bullseyes of dry regions that are developing. I'm looking at the integrated column soil moisture now, and it looks there's one bullseye that shows up southwest of Louisville, but it's fairly continuous across western Kentucky and northwest Tennessee, the dry area. So we'd probably need to look at time series analysis and see if there's anything that stands out with regard to precipitation inputs to see if that might explain something that might have happened. But no, there's not been a configuration change to answer your question, though. So it's probably a problem with the inputs.
And you can use the mesonet stations out there. A lot of them have soil moisture. Once it's back up and running, it's located in Bowling Green, so their fiber network is being rebuilt currently. So the mesonet's having some issues.
Well, thanks for bringing that up, raising that issue with us. So we can certainly take a look at that and collaborate with you on that.
All right.
Ingwe, do you have a question? Okay, you're muted.
Jonathan, go ahead.
Okay. Yeah, one question is that what is the repeater cycle for your data product, soil moisture data product?
So the repeat cycle would be in our real-time mode. We update it 4 times per day based on the GFS data assimilation cycle. So we're using the previous data assimilation cycle when the surface flux files become available to drive the model. And then we override the precip with the short-term MRMS precip rates at
And you are saying real time, so that means so the latency is really, epsilon small.
The latency is on the order of 2 to 8 hours for the analysis portion, but then we also provide forecasts, and that'll go out to T plus 10 days. So you're always going to have coverage in a real-time application.
Okay, great. Thank you.
Jonathan, I was wondering if you have any plans of assimilating brightness temperature directly as compared to assimilating soil moisture.
We have not explored the brightness temperature assimilation. Clay Blankenship is the one who developed that method to assimilate the level 2 swaths of soil moisture. And the one thing that, I don't know if his bias correction method would work. It could work if we did the brightness temperature, the L1Bs, but he develops bias correction CDFs for similar soil textures and land use types. And I believe that the soil texture based bias correction is the one that was implemented into our near real-time SMAP DA run.
Because one of the issues that is typically we have seen in data assimilation, if you're assimilating soil moisture directly, is the how you allocate the covariance matrix, and the model climatology a lot of times dominates, and you miss out the extreme events because of that. So that's something you may want to consider.
Well, we have noticed that if there is an extreme event, particularly an extreme wet event, the offline run versus the DA run tend to converge to the common wet solution, because I mean, if the soils are saturated and the SMAP sees saturated and shallow soil moisture, you're not going to really see much of any change. It's really during the drying episodes that you see the biggest differences with the data assimilation versus the plain offline run.
Okay, other questions?
Hey, Jonathan, this is Trent from Illinois. I really like the mapping, kind of the system here to pull on these, to compare these different products. It's really helpful. But I was wondering if there's any plans to add any functionality like a time series kind of tool. Like you mentioned, pulling out the time series when Chip asked his question to look at the drying. And from a drought monitoring standpoint, it would be really nice to be able to click on an area and to pull out the last 5 weeks worth of, see what the model's showing as far as variability and changes and things like that. So I didn't know if that was in the works or if anything you guys have thought about before.
Yeah, this was just those graphics I showed there on time series and histogram generation. We have Python scripts that generate those specific products, but we've only used them, on a manual or a case-by-case basis. But yeah, if we got more sophisticated with the way we served up data, that would be a really nice tool to have an interactive method to query the data and be able to pull out a time series at a particular location. So I agree with you, that would be a nice feature to have.
Okay, I've got a question for you, sort of following up a little bit on Chip's question as well, which I think this group would want to hear. You've alluded a little bit to how interactive you are with the user community and how you're really focusing R to O and O to R. Could you talk a little bit more about how that process works? Is there a way, I mean, I'm sure you guys accept emails from people on one-off questions, but is there any other kind of formal process to get kind of on the list to have a, some sort of new map considered, et cetera?
Yeah, so I don't know if Chris Hain is on, but he might be, he's the project manager for SPoRT, so he might be able to speak best to how somebody becomes involved with SPoRT as a new partner. I assume that's what. Yeah, I think we can hear you.
So yeah, so I'll address Trent's question real quick. So I mean, from a time series standpoint, we are looking for, one of our problems is we don't really have a mechanism to host the whole climatology. But we're trying to find a solution that will allow us to host the whole climatology, which will allow a user to interrogate, historical data, but also time series data on their, cadence that they want to. So yeah, that's something we're looking at, just trying to find the right solution. It's obviously a large data set and something that's beyond our normal SPoRT capability, but we do have other capabilities within NASA to be able to do that. So that's definitely something we are looking into. How to engage with us from like a partner standpoint? I mean, really just reaching out and talking, reaching out and showing your interest. I mean, we're always looking. That's why, webinars like these are really important for us to cultivate interest within the community. Like the whole point of SPoRT is that we want feedback from users to tell us what the forecast challenge is, tell us what their decision-making challenges are, so that we can tailor our tools to meet those challenges rather than us kind of doing that in a vacuum. For all of you on the call, I think, we're here as a way of saying we need your input, we need your feedback, and that's always met with enthusiasm from our team because while we're a relatively large team, we can only directly engage with as many people as we our engagement that we do is we try to do things like this to cultivate interest, but we really do want the people who are using the data to give us feedback and also say like what can we do to further engage. And we have a whole team dedicated to building and cultivating those relationships, and sometimes it's just having this mechanism here to like kind of introduce some of the work that we do and then to get feedback and then to kind of build some of those collaborations going forward. So I think that's kind of an open-ended way of saying some of this growth that we have, especially with our SPoRT LIS within the drought community, has been organic. We see people using it when we reach out to them. But if there are something you need, something you want, something that we're currently not providing, that's the kind of feedback that helps drive our innovation and drive what we can serve out to the community. So does that answer that question?
Yeah, it does. It does. I guess the other little part of it though is in some cases people may want, again, as Chip raised, a particular event that it would be, good to study a little closer. So that sort of fits in the same category, but it's a little more focused kind of approach to study. So, but what I'm hearing is, yeah, people should just reach out to you guys and say, hey, how about this? Or what about looking into this particular event, et cetera.
Yeah, and I mean, so one thing we're going to be starting in the new year that we'll kind of maybe reach out to some of the NIDIS people in the sense of how you guys organize your users is we're going to start kind of doing a quarterly or bi-monthly kind of I think we're calling it kind of like a stakeholder summit where we'll kind of on a 2 to 3 month period be kind of providing a webinar like this where we're producing or showing off new products that are coming from SPoRT. And obviously part of that is kind of building a user base that might be interested in attending those types of things. So maybe that's something we can talk on offline after this of how to kind of integrate, users within those communities or be able to share as we kind of roll up that activity and be able to share that beyond just our user group with, your user groups and, make sure that we're reaching all the people that we need to so that we can get that feedback and be able to provide that to the community.
Great. Chris, did you want to add?
I was just going to say real quick, a number of you have heard from me through emails as I've reached out to you about the SPoRT LIS and vice versa. So you can always reach out to me. I do, believe it or not, look at a lot of the emails each week that go through the Drought listserv, and anything that references the SPoRT LIS, I do pass that along to the modeling team, whether good or bad, because we need to know if someone noticed some problems or issues with the data or they used the data and it was great. So I always pass that feedback along pretty much on a weekly basis. But if it's something that it might be advantageous, we could set up some sort of a kind of a formal feedback form. I don't know if you can link something like that on our information page on the NIDIS portal, but I can get with the team about that, maybe come up with some sort of a feedback form, and then maybe if you're able and willing, we could provide you a link to put on there or something. So.
Yeah, that's a wonderful idea that I think we could generalize right across the many tools. So that's yeah. Let's talk offline, Chris. That sounds great. Okay. So we are just running a little over our formal schedule, but I just want to give one last moment for if there are any other final questions people want to raise verbally. And if not, feel free to use the chat. I meant to mention that at the beginning. If you want to carry on with another question on SPoRT LIS, but I think for now we'll turn to our next presenters. So thanks Jonathan and team on SPoRT LIS and welcome Shengwei and Rajat. So I'll be driving your slides, and if you're ready, but why don't you start with introducing yourselves? And just tell me next, obviously, when you're ready for your next slide.
Hi, I'm Rajat Binlish. I'm at Goddard Space Flight Center. I've been involved with the soil moisture missions for a couple of decades, and I'm also the SMAP deputy project scientist currently, and one of the developers of the soil moisture algorithm. So I'll go over a first few slides, and then Zhangwei, you want to introduce yourself?
No, you go ahead. Yeah, you go ahead, start. Yeah, okay.
So next slide, please. So the SMAP mission was launched in 2015. The objective of the SMAP mission was to provide high resolution, frequent revisit of global mapping of soil moisture and freeze-thaw state. And you saw some of the applications of SMAP data in the previous presentation that SPoRT LIS uses. It uses the SMAP soil moisture product directly into the assimilates into the system. The SMAP mission had two instruments on board. One was the radar, which was designed to operate at 1.26 gigahertz, and it had multiple polarizations, and it had a resolution of 3 kilometers. Other instrument is the radiometer, which has frequency 1.4 gigahertz L band, which is optimal for soil moisture observations, and it has a coarser resolution at 40 kilometers. And both of them shared a 6-meter diameter antenna with a conical scan of about 14.6 RPM and gave a swath width of 1,000 kilometers. And the orbit is sun synchronous, so it's 6 a.m., 6 p.m. every day over any location, local time. The radar gives you very high resolution data, but is more sensitive to surface roughness and vegetation, which makes the soil moisture retrievals more difficult. Whereas the radiometer gives you more accurate retrievals of soil moisture, but the spatial resolution is coarser. What SMAP mission did was combine the two instruments, and the objective was to use a combined radar radiometer type of approach to provide a course a high resolution soil moisture product using both the instruments. Unfortunately, after a month after launch, the radar failed, and we no longer have the radar, we just have the radiometer. But the good thing is, as you stated, the relative accuracy of the radiometer initially was 1.3 gigahertz, but we have noticed the radiometer accuracy is far better than what was designed for, and it has been giving us really good products, and we have been able to do enhanced resolution using just the radiometer based observations. Next slide, please. So the crop CASMA soil moisture products uses two different soil moisture data sets. One is the SMAP 9 kilometer original data, which is aggregated to daily, weekly timescales for the top, and the root zone soil moisture, which comes from the level 4 product. The other one is the 1 kilometer high resolution data set, which is again provided at daily and weekly timescale for the top layer. Both the 1 kilometer and the 9 kilometer data sets are also available in terms of anomalies and categories for the different conditions. And on the right, you see examples of the surface and the root zone soil moisture for a particular day. Next slide, please. So this graphic shows you the SMAP level 4 soil moisture product plus algorithm overview. It uses the GEOS FP model, which is run at GMAO at Goddard. It takes in precipitation observations, NWP surface meteorology, and uses a catchment model and assimilates brightness temperature, SMAP observations, brightness temperature, and produces a level 4 product, which is at a 9 kilometer resolution with a 3-hour time scale. It's produced globally, has a latency about 2 to 2.5 days. And you can look at the data, it's directly available at NSIDC and also through crop CASMA, and there are several publications on this product. Next slide, please. The next product that the crop CASMA uses is the 1 kilometer disaggregated Thyssum soil moisture dataset. It uses the 9 kilometer soil moisture and uses a disaggregation methodology, which is based, combines two different approaches. One is the thermal inertia approach, where it is, as you well known, that wetter soils have lower heat transport for smaller temperature deviations. And that is applicable when there is moisture deficit conditions. And other approach that we use is a soil texture based approach, where if you have moisture abundant conditions and lower temperatures, essentially your surface variability is driven by the salt texture, and that is what drives the desegregation process. These two approaches are combined using heat transport uh, uh, weighting criteria, which is described below. It uses latent heat and surface sensible heat from the NLDAS runs to combine the two approaches using a weighting approach. And on the right is shown is the 1 kilometer top soil moisture for the week of the first week of September using this approach. Next slide, please. The soil moisture anomaly data is computed using a typical, soil moisture minus the overall mean, and then divided by the mean multiplied by 100. And the soil moisture is the current value, which can be daily or weekly, as you're looking for whatever you're interested in. And then soil moisture is the historical averages for the 6 years of data set, which is the SMAP duration of the time period. SMAP was launched, as I mentioned, in January of 2015. The data started April 2015, so it has been operation for more than 6 years now, 6.5. Next slide, please. Sangvi, you want to take over?
I think you may be muted.
Sangvi, you're muted.
I think
Okay.
I just unmuted. Yes, I think we're
Okay,
good.
thank you. Yeah. Yeah. So Rajit just introduced that the original soil moisture data product for SMAP level 4 and also the 1 kilometer high resolution soil moisture data product he and his team developed. And also he introduced that the soil moisture anomaly. But the next thing is very interesting to us for the USDA is that how about to derive the data for that soil moisture crop on the cropland? What is the condition assessment? How we can map that? So the current NAS soil moisture condition report is based on the survey. So basically, it's a ground observation, So we have like almost like over more than 3,000 people, to watch the crop field every week, So the condition we defined is we have 4 categories that for the different crop. So the basically is that very short and adequate or surplus of the soil moisture for the cropland. So this is reflect that the soil moisture, the water needs for the soil from the soil moisture, So the results basically it's reported weekly in the publication as a summary at the county level. Some major state has the ASD level, so that's basically a region around that the 10 county, So this overall summary, but it really does not tell you where is dry, where is wet, where is normal, So there is no map. So next slide, please. Yeah. Okay. So the question is how we can derive a soil moisture condition map from the existing soil moisture map. We have the soil moisture map from the remote sensing, and also we have the field level observation. But the field level of observation just provide a statistic, a summary statistic. So this is the question we have. Next slide, please. So the thing is, the algorithm to do that, the soil moisture condition map is based on the fact that the summary report from the survey that's basically is a kind of histogram, or we can call the cumulative distribution of the soil moisture condition. And this information, luckily, we can also derive from that soil moisture map derived from the remote sensing. That is, so that here is the relationship based on that the histogram distribution relationship from the both data set. Then we can find a correlation, So where is that the cutoff line that for the soil moisture map from the remote sensing? So this is the relationship we can see here, is that for a given bracket of the very short, that value is already known from that survey report. And so we found that the cumulative histogram of the SMAP data, then we can find a corresponding percentage, so that we can find what is the soil moisture value is the point that's the cutoff value. So with this correspondence mapping relation, then we can classify every soil moisture level into a category of that soil moisture condition category. So next slide, please. So here is that based on that the category definition and classify cutoff or threshold, then we can derive that the soil moisture condition map. This is the condition map product. We see that it tells you where is the short area, where is the normal area, where is the surplus area. Okay, next slide, please. And yeah, this map actually shows you that the cropland condition, soil moisture condition on the cropland. Yeah, we applied that crop mask, so that the mask out the non-crop area. Next slide, please. Yeah, the crop CASMA is a web-based GIS application. So it actually has a bunch of tools developed, implemented over the interface that's based on the general browser. So it's a thin client architecture, so that anybody has internet access, then they can utilize this tool. And this tool has that two major data set that's already overloaded on that on the server. So we have a tool to user can utilize that tool to access the data and to manage the data so that you can visualize and not doing a very limited analysis. So also you can create a map, or even profiling a specific area. So you want to see a short period of history of of the soil moisture change dynamics. So this tool is very handy, and so that anybody can use it. There is no specific requirement for the software installation or any special specific training or knowledge. Basically it's developed for dummy. That's the philosophy we have for the development. So this is a tool is readily available for that data access and the data visualization, data analysis, and the dissemination. Okay, next slide, please. Yeah, here is some of the application case of this application. Yeah, so when this one shows you that the data and application is being used by NAS California Regional Office for their report. So this is a weekly report. So we usually have a summary report of the crop soil moisture, cropland soil moisture condition, but there is no map, so you don't know where it's dry, where it's wet. So they utilize this tool and the data set to produce the map and include in that the report every week. Okay, next slide, please. Yeah, this is the case that we utilize the CASMA and the data for that actually still this year. This is in June that the Mississippi Delta area flooding event. We usually assess that any extreme event happened, we want to see that what is the impact of that event happen and to that our cropland. So this one actually is the flood event. So after that we want to look at how much cropland that's impact, and so for the different type of the crop, and so what is the impact, the seriousness of that impact. So this one basically shows you that we have some kind of percentage for different crop, major crop basically here included. So this is very handy for this kind of assessment. Yeah, so next slide, please. Yeah, this one is showing the case for that.
Interrupting, but just want to do a little time check.
Okay, yeah, it's almost done.
Great.
This one actually shows that the drought and extreme heat wave on the western side this year. So this is basically every week we assess that the impact on the cropland. This showing that in Washington and Washington area we call the northwestern region. So this week actually covers 2 states. So this shows that within this on this July first week, what is the impact to the area. So what is the soil moisture level there? Yeah. So next slide, please. Yeah. This is showing the case. The outside user, they utilize this soil moisture condition data from the crop CASMA and compare that to the drought monitor results. And looks the two map, you will see that overall that the pattern is overlapped, you know. But of course, there are some difference in there. You will see that some areas that from the crop side, we feel that's very short, but general drought monitor indicate that it's normal. So there are some kind of inconsistency there, but still overall it's consistent. Yeah. So that means there are some value showing here. Yeah. Okay, next slide. I think that's it. Yeah, and here is the summary. Yeah. The summary, we only just trying to conclude that this application, the crop CASMA application, provides a platform for USDA agency, actually local area, and our headquarters, and also actually also as a outside user, you know, for assess and quantitative assessment, you know. And this is basically is very good. Is that this application provide a tools, a set of the tools for use that high resolution soil moisture information. So this is very useful tool and data, especially for that the irrigation cases. In irrigation area, the 9 km level 4 data is sort of two crosses to have a effective assessment. The 1 km data actually improved that a lot, so that we're showing that it's where is effectively irrigated, where it's short of the soil moisture. So this is the overall what we have for today. Yeah, thank you. Any question? Welcome.
Yeah. So any questions? We've got Dennis has got a comment in the chat, which maybe you can reflect on. We struggle with that issue in the Midwest, Northern Plains, its effect on soil moisture recharge. I'm sorry, Dennis, I don't remember what that was referring to. Maybe you can chime in on that.
That was a response to the previous one as an ongoing. It was not a question or a comment about this product specifically.
Okay, got it, got it. All right, well, any questions for this product? I know I'll want to ask the same thing I did with the other team, which is how you all are oriented towards taking user feedback or questions, et cetera, or if there's any kind of process to do validation studies or different particular event analyses. And Rajat, that may be more sort of directed to you, I guess, as one of the developer on the development side.
So on the side, we have done extensive validation studies. The assessment reports are available on SIDC. The SMAP data is available on NSIDC. People can send in their feedback. If anybody from the group has a question, you're more than welcome to send it to me. And I'll try to answer any questions related to this map. The assessment reports are done with every data release, and they are available online at NSIDC.
All right.
Yeah,
Any other?
Maureen.
Go ahead.
Marina, yeah.
Okay.
You referenced surface and root zones with this soil moisture model. What depths do those practically relate to?
Okay. Yeah, the surface is right now is 5 centimeter. That's basically is that the radium covers that surface. Yeah, the retrieve from that microwave, bright temperature. That's 5 centimeter. The root zone definition is 1 meter. So it's similar to the USDA definition. We are 3 feet, so that's around that 1 meter. Yeah. So that's the definition. Yeah. Yeah. As for the feedback, yeah, we don't have a specific channel for that. Actually, we have that email address on that application. So on the crop CASMA application. So any question or tech support, you can send the email there or send the email directly to me or Rajat. We can, we definitely will address that. So I actually got that lots of email, yeah, some phone call, from the user. Yeah. So that's most of the call. It's related to that how to interpret data and how to utilize the tools, to function or something like that, and some data format or something like that. Yeah, download the data or that kind of. Yeah. Yeah.
Okay, and then another question, if no one else has got one, I'm just curious if you are all in, assume sort of, oh, we just got a question from Dennis. Let's do that one first. Are the crop soil maps?
Yeah, you talk about the crop soil moisture maps using the NAS data. Are those available publicly?
Yeah, all these data are available publicly. Everything on the crop CASMA that's publicly available, it's not confidential. Yeah. So the original survey data, that's confidential. So that's the summary results from NAS that's published. That's not confidential. But the original results reported by that survey or farmer or volunteer or extension employee, that's confidential.
Do you have like a website that you can point us? I mean, obviously, is it available from the main crop CASMA where you did show kind of those more, is that what you're talking about, Dennis, like the more based on the survey reports? Is that what you're referring to? Because I don't know if I've seen those on the crop CASMA website.
Correct. I'm trying to find it right now because I don't remember seeing it either.
For the based on the survey, you mean the map?
Yeah, like the more high resolution map that shows the survey terminology of very short. Are those
That's on
available?
we have let me see. We have That's the terminology definition that's in the document, user's guide on that crop CASMA. We have a link. We have a tab that shows say that's the documentation. Click that, you will see that. Can I share my screen?
So, Zhang there, it's less about the documentation, more about the actual maps that are created with that scaling, with the in the short, very short that you showed in the presentation towards the end. Those very high resolution, sometimes, well, state level or county level maps.
No county level. Basically, it's a state level that's public.
And where are those?
So you can go to the left tab and then pick different layers. When you go to the layers, you have to pick categorical.
And the other thing is this: for the high resolution, we just recently developed a product. It's based on the survey data, but the survey data we cannot publish. That's has to be confident by law, so we cannot release it. So we basically did some kind of smoothing, utilize a kriging method to smoothing with that neighborhood county, so that we smooth it and then publish the map. So they give you some ballpark idea, so what is the situation around that area, but it's not accurate to that county or something. To the county, definitely is not accurate, but it tells you that that area is, is wet, but not necessarily means that the county, a specific county, is wet or dry. So
okay.
So
Rajat, you were going to give us a sense of where that
is being published. I think that's just recently. Yeah, but that's purely based on our survey result. Nothing remote sensing there.
Right. Okay.
Yeah. So
yeah. Okay,
so I'm not sure. This is a sort of like give you some reference, a sort of reference, not but definitely it's not. I'm not saying this data are correct or wrong, but it's not the ground truth. That's one thing you gotta keep in mind.
Right. Okay. I'm gonna stop you there just because we are running out of time. Just want to ask Rajat, it sounded like you were just about to say how people could get it off the crop CASMA or another place, those maps.
So the categorical remote sensing based categorical data are available on crop CASMA. On the left tab, if you go to the default is anomaly, but you can select categorical and then you will see the categorical maps, which are remote sensing based only. What Zhang is talking about is also the survey information, which is not available online.
Right.
And I was just going to mention, I'll make sure to capture that in the notes so that we can kind of know how to get to that part. So I can see those now. So thank you for that.
All right. Any last questions? We are almost out of time. Okay, well, thank you guys very much for your time. Really appreciate that. And I think you all know we are starting a spreadsheet that has the different tools described and some of the specifics about the resolution, latency, et cetera, which I've shared around. We'll be continuing to build on that. Also, the developers have both of them have shared some of the reference materials that they use, some of the peer-reviewed journal articles that validate their algorithms, et cetera. So we'll be compiling those and sharing those around as well. But really appreciate everybody's time today. We are it looks like we are really going to have used an hour and a half, but we would like feedback from those of you in the audience as to whether this was good pacing, or if you prefer that we tighten things up next time. But again, sort of did seem like we needed that full hour and a half to go over the materials. And I think that's it for now. Really appreciate all of your efforts. And Molly, I'm going to turn it over to you in case there's some last minute things to go over.
Nope, no last minute things. Just thanks everyone for joining, and we will send out the recording and the notes for everyone, as well as the contact information for the presenters. So yeah.
Right, so look out for that from us. And also we will be planning to have a lot of this posted on our website over time, so that, thank you again, developers, that's part of the point of recording. This way we can keep your words immortalized until you decide you want to update them for us. So all right, well, thanks everybody. Really welcome you. Well, thanks for coming, and